Friends, we are continuing with our conference, AI Journey. Today we had a very tight agenda during the day, many complicated topics and big presentations, a lot of insights and the most relevant information. In our final session, we have prepared the session of Q&A. We'll be able to answer your questions and to talk with the speakers in live broadcast. We will be joined by Director of Laboratory of INSEA, Jürgen Schmidt-Huber, the Head of Department and Professor of Computer Science in the Department of Computer Science at the Oxford University and a Senior Research Fellow, Michael Wooldridge, Director of Neuromorph Compute Lab of Intel, Mike Davis, the Director for Research of ML of NVIDIA, Ani Mashri, Anand Kumar, the CEO and the founder of SingularityNet, Ben Bertzel, and the Director for Research and the Head of the section in New York of Facebook AI Research, Lawrence van der Maten, and Michael Hein, Distinguished Research Staff Member in the IBM Research AI Department in Yorktown Heights, New York. A question to Jürgen Schmidt-Huber.
Do you think if we achieve singularity and AI frees us from the need to work at all, do you think that would be a boon for society? Do you think that would be good? And what changes will this trigger in society?
So you are asking, can you hear me? Can you hear what I'm saying? Okay. So you are asking,
yes, we are.
What would happen if AI is able to do all the work that at the moment have to do? Will that be good or bad for society?
Да, совершенно верно.
Yes, that's right.
I'm not sure whether people are going to get happier than they are today. Nevertheless, they are going to accept that new situation and will arrange themselves with it. We have to see that even today, most jobs that we execute are luxury jobs, and there are just a few really essential jobs such as farming and building houses and warming up the houses, and all of that can be done by less than 10% of the population. And most of the jobs that people have today are luxury jobs such as, you know, writers and journalists and Facebook influencers. Although they spend a lot of time on all of that and they are really dedicated and competing with lots of other influencers and whatever, it is not obvious that you need these kinds of jobs for the survival of mankind. So, already now we are in a situation where we can learn something from the present about what it means to live in a society. Much of the hard work is done by machines, such as in agriculture and many other fields.
Не люди.
Jürgen,
thank you very much. And then there's another very interesting question. What areas in the development of AI do you think hold the most promise, and what are going to materialize in the nearest future? And what do you think the most effort should go into? What resources should go into the most?
Is that a question to me again?
Да.
Yes, it is.
Wonderful. Yes. So what is most promising? Well, let's first say where are most of the profits in AI? At the moment, most of the profits are in marketing and in selling ads. So the big platform companies on the Pacific Rim, such as Alibaba and Amazon and Google and Tencent and Facebook and so on, they are using artificial neural networks and deep learning to predict what are you going to read next, or what is it that you want to read next, given all the other things that you have read in the past, and which websites would you like to see next, given all the experience that the platform has collected about you in the past and from a million other people who are a little bit like you, who are similar to you. And so all of that is very profitable because it is sufficient to make these platform companies pretty much the most valuable companies in the world. However, marketing and selling ads is just a tiny part of the world economy, and the big thing of the future is going to be all the rest. So AI in the physical world, not just in the virtual world and on the World Wide Web and in video games and so on. No, real robots in the physical world, controlling industrial processes and controlling all kinds of complex machinery that at the moment has to be directed by humans. And the big challenge is how to really achieve the thing that you see in the movies, robots that quickly learn from few interactions with the environment to become smart enough to achieve goals in a previously unknown environment. And that's what we are focusing on. AI for the physical world, going beyond the virtual realm. AI in the physical world is going to be the big topic of the future, and it's going to affect most of the economy.
Большое спасибо, Юрген, очень интересно.
Thank you very much, Jürgen. Very interesting. In one of your interviews, you mentioned that you convinced Elon Musk not to fear AI. You said that artificial intelligence, having exceeded us by the level of development, might actually lose interest in the people. My question is, do you think this is actually a plausible scenario? And if yes, then how important is it for us, humans, to create an artificial intelligence that is superior to us humans in everything?
So we not only have these AIs that slavishly imitate humans, but we have had for decades these more interesting AIs that invent their own problems, that ask their own questions, just like a scientist not only is trying to solve problems that are given to him, no, he is inventing his own problems. And so we have these artificial systems, reinforcement learning systems, that get a reward for inventing their own experiments that tell them something that they didn't know about how the world works. And so these AIs that set themselves their own goals, they are going to dominate at some point. Not yet. At the moment, almost all AI is just there to serve humans. But at some point, these really interesting AIs are going to set the again, I believe. And then the question is, what's going to happen when they are really super smart and much better problem solvers and much better self-inventing problem solvers than humans? And once that point is reached, then we can ask ourselves, should we be afraid of them, or should we fear them? And I think in the long run, there is a protection of humankind through lack of interest on the other side, because most beings are mostly interested in other beings that are similar to themselves. That's why most politicians are interested in other politicians of the same kind. Most CEOs of companies are interested in other CEOs of competing companies. Most 5-year-old girls are interested in other 5-year-old girls, and most frogs are in other frogs of the same kind. So most of the super smart AIs of the future are going to be mostly interested in other super smart AIs of the future, and not so much in the frogs. And that's what I mean by protection through a lack of interest on the other side in the long run. However, at the moment, we should point out that almost all of AI research is really just focused on making human lives easier and longer and healthier. That's what my company is doing. That's what many are doing. Because people want to buy stuff if it helps them, and they are not going to buy stuff that is not good for them. So there's immense commercial pressure towards good AI in the sense of AI that is serving humans.
Jürgen, большое спасибо.
Jürgen, thank you very much for your response. Those are very impressive responses, very many things to talk about. And I'm addressing other speakers now. If at any point in time you would like to say something of your own in response to a question directed to another person, please do so. Now, my question goes to Michael. In your talk, you cited interesting cases of limitations in AI. My question is, in your opinion, what are the ways to overcome these limitations?
Michael Davis.
Michael Davis, thank you.
Yes. You can hear me? I think in our research at Intel Labs, we believe there's at least one promising path for this, and that's to return to the brain and look for bottom-up inspiration from how we see biological brains solving these kinds of problems. So we're taking kind of a reductionist approach of looking at the basic principles of neural computation and seeing how these circuits can first learn quickly, for example, and that's addressing one of the limitations today of our AI systems that tend to require large quantities of data to learn. And beginning with very humble initial ambitions, which is just to learn at the sensory level, maybe new odors, for example, that haven't been presented before, and moving beyond that to more abstract notions. But our objective is not necessarily to go beyond the limits of AI in terms of a general AI agenda, but more to deploy AI to reduce its power requirements and improve the speed and the processing time that's required today, which is allowing us to advance this technology out of the data centers, what Jürgen was speaking of, and putting it into the real world where these systems can adapt and interact with real world data that's arriving in real time. So that we believe that brains, there are a lot of low-hanging fruit, so to speak, of insights and understanding that we can find with relatively little effort by studying the actual neuroscience science and harvesting that into new insights into computer architecture.
Спасибо, очень интересно. А смогут ли когда-нибудь возможности?
And do you think, at some point, the capabilities of neuromorphic systems, do you think they would be in a position to match the capabilities of the human brain? And if yes, when?
Well, I think, in principle, yes, certainly. I don't think there's anything physically, no physical impediments that would keep us from achieving that in time. Now, the question of when, I think it's very, very hard to predict. And I think you have to consider, in what context for what kind of tasks. So I think we can achieve human levels of adaptability and response times for, say, robotic control in quite relative near term, within a few years. Now going to the capabilities of being able to learn abstract notions and form associations and similarities in a hierarchical manner, spanning different levels of semantic understanding. I mean, this, I really don't, would hesitate to offer a prediction, but we're certainly quite a few years, many years from that, I believe.
Интересно, как это много и
Well,
мало.
I wonder how many is many years and how few is few years? Is that tens or is that hundreds of years or is that... I mean, everyone wants to land in the future. So my next question is, what do you think should be done today for someone who wants to go into neuromorphic research in the leading labs of the world?
Как попасть туда?
How do you become a fellow of your lab?
So the neuromorphic research is perhaps a bit unique in how multidisciplinary it is. So it's, you know, a background in computer engineering, computer science, electrical engineering, these are all very useful. But one of the challenges is that it requires rethinking computation itself down to the basic physical basis and really throwing out much of the intuition and understanding that comes from decades now of study in conventional computing. So I think a grounding in some of the fundamental sciences like physics is incredibly useful actually in the field of neuromorphic. And so I encourage people to really take this first principles approach and begin with things like dynamical systems and mathematics. And I think the people that we've seen do some of the best work in this field are coming from those kind of backgrounds, non-traditional science backgrounds that really are not hesitating to go beyond the traditional notions of computer science and what programming and computer architecture means today.
Майк, спасибо. Я думаю...
Thank you, Mike. We obviously would like to speak more with you, but we are certainly limited on time, and thank you very much for being able to take at least a few questions from our viewers. Great answers. Thank you very much. And my next question I would like to direct to Ben. A question to you, Ben. Hello again.
Вопрос. Как человек, который верит в дружелюбие...
How a person who believes in friendly artificial intelligence, do you think by the time that AGI arrives, the society would be prepared to accept such technologies? Or do you think the Skynet image is too firmly embedded in the heads of the people now?
I think that the reactions to AGI as to any radical new technology are going to be, heavily mixed across nationalities and across generations. So I mean, I'm still aligned with my friend Ray Kurzweil on timing. I mean, he projected we'll get to human level AGI around 2029. I mean, there's significant error bars there. It could be even sooner. It could be later, but I think that's the right order of magnitude for the mean of the distribution that we're looking at. I don't think it's like 50 or 100 years or something off. And that becomes pretty concrete. Like if you take the hypothesis AGI comes in about a decade, and I look at the people I know, like most of the people I know who are, say, under 25, they don't really want to deal with getting a job. They'll be pretty happy if the AGI can do all the work and they can dedicate themselves to other sorts of intellectual, spiritual, social, artistic advancement or whatever. And I don't think they're walking around obsessed with the Terminator. I think they've grown up in a world where they're ensconced in technology all the time anyway, and they don't know what to do when the internet gets turned off. So I mean, my thinking is young people are growing up in a world where AI is already a presence and is getting more and more prevalent all the time, and it's going to seem almost like an inevitable and natural development. Of course, there's going to be many people, particularly older people, who get their meaning through carrying out job functions, and who will, they'll miss vacuuming the floor and washing the dishes. I mean, that's been the case with every disruption. We just, in the history of humanity, we don't look back now and wonder how the transition from hunter-gatherer to agricultural society, how that disrupted some of the elderly hunter-gatherers. Probably quite a lot, right? But things moved on, and there was disruption. I think that's not what we need to worry about. What we need to worry about is actually making the AGI become friendly. If we get to friendly AGI, the disruption will be manageable. The issue is, I feel some of Jürgen's comments were a little bit optimistic. I mean, I've said many times, like the main application of AI today, as you point out, there's advertising, there's Wall Street and so forth, which is arguably exacerbating global wealth inequality. There's military and espionage, and these are all part of human life and human society. We're not gonna get rid of them. They're part of the overall system. And now Jürgen's company is doing a bunch of great stuff, applying AI to matters of broader social benefit. And I think we need more of that. I mean, we need more AI for medicine. We need more AI for education. We need AI for social welfare. We need AI for fundamental scientific research. And all these things are happening now all over the planet. But I think we need to dial the balance more toward AI for broad benefit so as to maximize the odds that we get to a friendly AI. Because it's not the case that, as Nick Bostrom and others have claimed that, a super intelligence that annihilates us all and turns us into extra hard drive for itself is somehow a very likely outcome. I don't think it's a very likely outcome, but I mean, I do think there are bad and good outcomes from a human perspective that are plausible, and we should be doing more to bias toward the friendly AI outcome. And if we can do that, I think the disruptions and transition issues will be manageable.
Ben, thank you. Very exciting indeed. I think that we have talked about and start discussing, some huge topic. Would be nice to discuss it too. But another question: to what extent it is important to make sure that the researchers share the results of their developments in AI, so that we have a common shared space? And this is how can we accelerate our progress on an exponential. How is it important? To what extent it is important? Thank you.
I think that open sharing of knowledge in pretty much every field of research is incredibly important. I mean, to a great extent, almost all science that happens today is conducted by the group global brain of humanity. Like, it's no more like some mad genius sitting in his basement for 10 years and coming up with something totally new and totally disconnected from the whole of society. Really, the innovation is largely happening on the level of a large cultural group, which I have mixed feelings about as a human being. I like the feeling of making an individual contribution, but I mean, I think what I'm describing is the reality. And because of that, what we see in the world today, including in the AI field, we do see a lot of open sharing of ideas and algorithms and even many machine learning models trained on data. And I think that's a bright spot. It's been quite fascinating because the AI field, it's primarily being driven by algorithms and data structures and concepts that are published in peer journals, posted on arXiv, and they're reflected in open source code that's out there in GitHub. Now, the data sets are being held by large companies and in some cases government agencies. And so the knowledge gained by AIs based on looking at specific data is being held in a proprietary way. But actually, open sharing ideas is happening. I mean, right now there's a lot of tension, as an example, between US and China, but there's open sharing of algorithms and code between guys at Tsinghua University and MIT and so forth. And I think this is because there's just so much more efficiency and effectiveness in moving forward on the research level with a more open sharing of knowledge. And in general, I think we have two large dynamic patterns in the global economy now, right? There's a pattern of concentration of resources in a few large organizations. I mean, including the Pacific Rim advertising companies, as Jürgen mentioned. But there's also the rise of decentralized sort of peer-to-peer networks, like the internet and arXiv and GitHub, and then blockchain networks like SingularityNet, which I'm involved with. And we have both of these going together. And what we have now is quite fascinating in that the research is more on the peer-to-peer decentralized open side, but the practical deployment of AI is heavily in the, concentrated in a few large organizations, which is very interesting dynamic when you sort of cross-correlate it with the advent of friendly versus non-friendly forms of AI during the next decade or so.
Man, it's very interesting to listen to you. Great experiences, really. I'm pretty sure everyone is excited with your answer. Thank you so much for your time. Have to give the floor to Lawrence now. Now, Lawrence, a question to you. Can models, ML models, identify malicious incoming information, and what mechanism will help to improve ML model in terms of identifying malicious data? Thank you.
That's a great question. I mean, it depends a little bit on what you mean by malicious input data. I think one of sort of the key functions of machine learning in a company like Facebook is to use machine learning to recognize all sorts of undesired content, whether it is misinformation or child exploited imagery or things like that. There's a lot of AI being built to identify those kinds of inputs and automatically filter them from Facebook platforms. And so I think in short, like the answer is yes, right? Like there's a very important role for machine learning in doing that kind of work. I think maybe what your question is referring to is more to the topic of adversarial examples, right? So sort of the security implications of machine learning models, right? So like, is it possible to circumvent these systems? And I think in short, right now, the answer is yes, right? Like there's a lot of studies demonstrating that you can generate these kinds of examples relatively easily, right? So these are examples where you make small perturbation to the input data, causing the model to create an incorrect prediction. And these are, from a machine learning researcher point of view, they're really interesting because they tell us something about the ability of our machine learning models to generalize, which may not be as good as we want them to be. And there's interesting questions there around sort of how to improve that situation, and there's sort of a constant back and forth, I guess, there between people developing or researchers developing defenses against such adversarial inputs, as well as designing more effective attacks. And I expect that will continue for a while. But I'm excited about that general progress, because I'm hopeful it will teach us something about the generalization capabilities of our machine learning models.
Лоренс, очень интересно отвечаете.
Yeah. That's a great answer. Thank you so much. Another question pertinent to basically everyone, I think, just usual users. What piece of advice can you give to the people who are concerned about the confidentiality of their private data? This is, of course, pertinent during our big data era. What recommendations can you give? Thank you.
Well, there are technologies now, many of which are rolled out. Some others of which exist only on the research side and still need to be deployed widely. But I mean, there are technologies now that allow machine learning, machine reasoning, other AI technologies to operate on encrypted data. We have multi-party computing, homomorphic encryption, and so forth. So I think on a technical level, the problem of data sovereignty and privacy preservation it's hard, but it's substantially solved, and it's not harder than a lot of other things we're solving. So I mean, really, I think again you're back to the sort of organizational and industry structure issue, because I mean, most people can't validate that the homomorphic encryption code is doing what it says it's doing anyway, right? So I mean, you're placing trust in the organizations that are operating all these things, and that's going to become a more and more interesting issue as we unfold toward human level AGI. Because I mean, if optimists like me are correct, within a decade, it may be human level AGIs that are making strategic decisions for the big tech companies and also writing a bunch of the homomorphic encryption and machine learning code. And then, I mean, they're somehow placing a trust in the overall network of human digital minds that's regulating this whole system, right? So it really comes down to a social network trust issue above a technology issue, because I think we do have the technology to enforce all sorts of privacy protection, that democratic governance, and unbiased AIs and so forth.
Честно говоря, даже...
I would second Ben's answer. So one of the things maybe worth mentioning is one of the projects we're working on is a project called Crypten, which you can basically think of as an implementation of PyTorch that is backed by secure multi-party computation, so that performs the same computations that PyTorch would perform using the same API, but the unencrypted data that is shared between parties rather than owned by one central entity. And the goal is of that project is exactly to sort of spur technological development in that direction, to be able to do machine learning in a more privacy-preserving and secure way. And I think part of that, and this comes back to an earlier one of the earlier questions, in doing that, in order to get that trust, it's really important to be open, right? To sort of do that technology development in the open by publishing about it, but also by doing the development in open source, so that other researchers can audit the implementations and check that they actually sort of provide the security and privacy guarantees that they promise.
Thank you so much, colleagues. We have a question to Michael Hind. Michael? Good afternoon, or good evening, rather. For a successful development of AI, to what extent it is important to support the trust to this technology from the part of the society, building on our previous questions, and what tools and measures would help to increase the trust of the society to artificial intelligence? What do you think about that?
Sure. So there's a number of things. One aspect is you'd like the AI system to actually work and be correct in most cases. That's sort of the first part. If I'm going to use an AI system to detect cancer, I would like it to be accurate close to 100% of the time. The next level after that is to say, well, how does it work for different people? Are there issues in terms of bias? Does it only work on white males, maybe, or other demographic groups? The next level is to say, well, okay, it tells me I have cancer. I'm a little surprised by that, and I'd like to know more information. Can you give me some kind of explanation of why do you think it? Can you show me some reasons? What characteristics on the scan, let's say, or examples of other cancerous people who had cancer that you can point to give me some level of confidence? And the key part with that is to know like who I am. Right? I could be a machine learning researcher who really wants to improve the algorithm. I could be a physician who knows medical domain very well and wants to understand why the AI thinks it's cancerous. Or I could be a patient who knows neither AI or knows the medical domain, and they just want to get some level of confidence that this is a good diagnosis. Should I go to a second opinion or a third opinion, and so on, because these are very high-stake decisions. So it's a combination of all those layers. It's certainly accuracy. it's accuracy, appropriateness to me in particular, and not having sort of bias. And then the third level is explanation about why, and why do we think it's actually a good diagnosis.
Michael, thank you so much. Could you tell us about the peculiarities of IBM approach to the development of AI based on trust? Something that you mentioned.
Yeah, and absolutely. So what we've done in IBM, and particularly in IT research where I live, is we've got several dozen people working on these problems of fairness, of explainability, of transparency, AI governance, robustness that was talked about before to adversaries. What we saw was something that was kind of unique, or unique from my background at least, that we had lots and lots of scientists in IBM and elsewhere who cared a lot about these topics. Lots of conferences and workshops, people publishing papers. And we had society who also cared a lot about these because they were impacting them now. So it's a great place to do research in that society cares about your solutions. But we saw there was a big gap because not necessarily everyone, a medical practitioner is not going to go and read a paper in the top AI conference because it might be too hard. So what we decided to do is release a bunch of open source toolkits in these spaces that allows us to bridge the gap, to basically take what the scientific literature has done and put them in code in a sort of a common place. So if you want, say, to measure bias, we implemented a whole bunch of different ways of doing that and ways of mitigating bias all in the same toolkit. So it allows a practitioner to, for example, to try them out and see which works best in their particular scenario. And we've done the same thing for adversarial robustness and for fairness. So that's our strategy, is to really help take things from the lab, of course, put them into IBM products, but also put them into open source. The whole community can benefit. It's what I think Ben was talking about earlier, of how we share information in terms of papers, but also share information in terms of actual code that people can use.
У вас потрясающая работа.
Great, you're doing great work, fantastic company. So, dear speakers, thank you so much for that lively discussion and for your detailed answers. I think it was very important for our listeners. It was a great format. It would be great to see you again. And we would like to thank the partners of aijourney for that support so that they delivered such a great conference. Intel is a direct way for high-tech compute. Huawei helps to spread AI everywhere. MTS is a leading Russian company to deliver digital, media, and telecom services. SAS, where you can get a consultation on the booth and get to know the applicable solutions. That is the only leader in all the ratings on AI. Rosatom, the Excellence Center for the National Technologies and one of the leaders in implementing digital economy program, and the new production technologies, one of the co-executioners of the roadmap. And the fund of investments have already attracted $2 billion to support the companies that focus on AI development. We would like to thank the fund of Skolkovo also. So thank you for all your support. We have to move forward. And we need to sum up the results of the first day. If it was one word, I would say the agenda was tight. 78 speakers from the companies, from the leading companies, 78 speakers, 42 academic hours of all reports and discussions. And this is just the beginning. So intense is the word. We talked about 75 relevant topics related to AI, and the perspective, had a scientific perspective on the AI. We talked about ML, AI, recommender system, confidentiality, computer vision, speech recognition, But the most important thing is that we were able to kind of thaw the ice. Despite all the distance, we had a very lively and friendly discussion. Thank you very much for your attention. And tomorrow we're going to continue to discuss artificial intelligence, and we will continue to share the experience and how it is relevant for the state, for the business, and for the society. We'll talk about the ethical questions related to AI. You can select and customize your schedule to benefit the most from our conference. This is it. See you tomorrow. Thank you so much for being with us, and have a great evening.